So here's the cosine function that we're going to work on right now. We're going to use WAkh. The H goes last. Here's the A, the W, the H, and the K. And we talked about this a lot, about how each of them affect our graph. So let's go in order. We're going to use, let's see, the first one that we're going to do is W. So we're going to say W, and then we're going to do A, then we're going to do K, and then we're going to do H. H is the last one because he's the most fun one. Yeah, right? But it has to be W-A-K-H. Okay, so W changes the period. That's the first thing we have to look for. Now, before we get started, though, what is weird about this function when we compare it to our template down here? Okay, there's no K. All right. Now that's not that bad. That just means it doesn't move up or down, right? Now there's something else.
W.
Yeah. What about the W?
It's not there.
Okay. W is what multiplies to X. Is there something multiplying to X?
Yeah.
Okay. Actually, that's a 2.
Oh.
Okay, down here it's a 1, and then the W multiplies to that. But here there's a 2 multiplying to X. Now that's weird. Okay, so what we need to do is we need to factor that 2 out. We want to make it look like our template down here. So just erase it. No, you can't do that. We have to do math with it. Okay, so we're going to have negative 1.5. That stays the same. And then the cosine stays the same. But we're going to take that 2 out and put something new inside my parentheses. So if I divide 2x by 2, what do you get? Just x. Now this one's weird.
Wait, how do you do it if that's divided?
How do, like the pi over 3?
Yeah.
Yeah, that's what you're jumping ahead of me, girl. Come on, calm down.
Wait.
Okay, so
Wait to get just x.
if I divide 2x by 2, I get x. Now I need to divide pi over 3 by 2. Now that's weird. So let me write it out for you. We have pi over 3, and we're going to divide that by 2. Now, we don't like dividing with fractions. Instead, we multiply by the reciprocal, right? So we're going to say pi over 3 times the reciprocal of 2. What is this reciprocal of 2? 1/2. So this equals pi over 6. Oh, so that changes our h. We get to see the true h now. The true h is pi over 6. So now, let's go through our WAkh. Let's do W first. W is the 2. In this case, it's multiplying the x. We know that the W changes the period. And we find the period by going 2 pi, which is the OG period. Or I'm trying to draw a G. OG period. The OG period is 2 pi. And we're going to multiply that by the reciprocal of the W. What is the W in this one? It's 2. What's the reciprocal of 2 again? 1/2. So if I go 2 pi times 1/2, that would be, let's see, let's get rid of this and put a 1 underneath it. We multiply, wait, can we cross cancel? Yeah. So we get pi. That's our period. And then we go over to our cheat graph, and we put pi right here. Now I need to label the rest of these x's. In order to do that, I take the period and divide it by 4. So period divided by 4, and I can't simplify it, so that's what I use. I have pi over 4, 2 pi over 4, 3 pi over 4, and then this would be 4 pi over 4, but I don't need to write that, because that simplifies to give me pi, right? Okay, and then this one actually simplifies too. This guy right here, he simplifies to be what?
Pi over 2.
Alright, so let's simplify him. We get pi over 2. After we do that, we do the amplitude next. Alright, so we finished with the period part. Now we do the amplitude. Now this amplitude's special. He has 2 special things about him. One is that he doesn't equal 1. He equals 1.5. So that just changes my amplitude to 1.5. Instead of it being 1, which is our normal sine and cosine function. Normal sine and cosine functions have an amplitude of 1. Alright, so that's our amplitude. Now, our amplitude is always positive. So what does that mean for the negative? What does the negative do?
It switches our max and min.
Yeah, it switches the max and the mins. So we know cosine. Cosine normally starts with its maximum. It normally starts like this. It goes whoa, like that. And it's normally at 1, it goes down to -1. It starts right here. But because it's negative, it's going to start down here. Does that make sense? So it's going to go like this instead. All right, so let's start right here, which is about where 1.5 would be, right? That's about where 1.5. And then we go to center line. And then we go to 1.5, back to center line, and then down to -1.5. Now, notice that I did not put numbers on my y-axis yet. It's very important that you don't, because this is our cheat graph, and I'm trying to not have to write as much. After I finish the amplitude part, you can connect the dots, because we're not going to have to redraw it, because this is our cheat graph. Next, we have the k. Now, there's no k on here, right? So we don't have to worry about the k. So if we don't have to worry about the k, wait, what does the k do? It shifts it up and down. That's what the k does. And so because it shifts it up and down, and we're not having to go up or down, then we stay at 0. So these numbers are 1, 2, this is -1, -2. We didn't have to change those numbers. Now if we did have a k, we would change those numbers. Like, for example, let's pretend that there was a plus... No, let's do negative, because we did plus last time. Let's do, say, +3. No, let's do -5, okay? So what would our center line be? That'd be -5, and then we would have to put in our other numbers, like so. Does that make sense? That way I don't have to redraw my graph. That's why I call this my cheat graph. But we're not shifting here because there's not a k, so I'm going to put my other numbers back.
So then on the real graph, would you only see part?
That's a good point. K finds the center line. That's a good way to remember it too. K gives you the center line. So since k is 0, our center line is 0. I like that. Okay, so let's transfer this over to here. What's the last thing we have to do? H. That is the horizontal shift. That moves it left or right. Okay? Now, stay with me on this one, because this is a stretch right here. Now, if this is shifting to the right, wait, it's shifting to the left because it says plus pi/6. You guys see this right here how it says -h?
Yeah.
And see right here how it says plus h? Yes. What would pi/6 have to be right here to make it plus h?
Negative.
Yeah, it would have to be, you would have to have a negative pi/6 right here so that the negatives would cancel out. You guys see that? Yeah. So that's your phase shift. Your phase shift is negative pi/6.
Wait, so even if it's positive, it's still negative?
Yeah, but if it was negative, then it's positive. So it switches. Okay? Oh, and I forgot to put in my y-intercept. My y-intercept was negative 1.5. All right, so if we're shifting to the left pi/6, that means, oh man, what do we have to do here? We have to move all these points over. We move those points over how much?
1.5. I mean, 1.
Pi/6.
Yeah.
We move it to the left pi/6. So every point right here has to be shifted over to the left pi/6. Now, I don't like drawing multiple graphs on a graph, so now I'm just going to put it over here so I can be done. So let's look at that first point. That first point is 0, -1. Let's see, 0, -1.5. If I subtract pi/6 from 0, what would it be? It'd be negative pi/6. Now, I'm writing it out so you guys can see it, but you don't need to write that out. So at 0, I go to the left 1, and that's my first point. Wait, I have to go down to negative 1.5. And then this one right here, pi/4, I'm going to write it out so you guys can see it. Pi/4, what's the y value for pi/4?
0.
0? Or it's on the, yeah, it's on the center line there, so it's 0. I go over to pi/4 on my graph. You guys see it's right here. It's between these two tick marks. That's where pi/4 is. I have to shift it over 1. So it's going to be right here. Now I'm going point by point. So I have 3 more points to go. Now pi/2 is at 1.5. But I don't. It's not pi over 2. What is it? See, it's at pi over 2, and I have to shift it to the left once. Now, so it'd be pi over 6. No, this is actually pi over 3. But we shift pi over 6 once, and then we can go up to 1.5. You know, I think I forgot to say or mention again that these tick marks are counting by pi over 6. Did I forget to mention that again? I did. I said it earlier. Okay. So this is pi over 6. This would be 2 pi over 6. But that's good to know because since we're only shifting pi over 6, we only have to move one tick mark each time. So here's the next point right here. 3 pi over 4. 3 pi over 4 would be between these points right here. Wait, sorry. Right, this point and this point, it'd be between those. So if this is pi over 4, I shift over 1. That means that's where that point goes. And then my last point is pi, is at pi. And so I shift over 1, and that's where the minimum goes. And so I have my first period for this graph. Okay, but now I have to do it multiple times. Okay, because we have to finish the rest of it. So we get, I guess we're just copying the points, but now we just have to count by pi over 4. So you see with the space between this one and this one? You see that space? That's like 1.5 tick marks, right? So I'm going to use that to cheat a little bit. I guess so 1.5 would be right there, and then 1.5 would be right there. So I'm going to put my max right there. And then 1.5 would be right there, so I'm going to put my intercept right there. 1.5 would be right there, so I'm going to put my min right there. And that's enough right there. Okay, I'm happy with that graph. Omar, you gave me a good idea. Hold on. Okay, so that was complicated. I went point by point. Now stay with me. This is going to be nice. Okay, Omar's just gave me an idea. He said, what if we just take these x-intercepts and shift them 1 point? Ooh, that's a good idea. So this is pi over 4 right here, right? And I'm shifting it over pi over 6, right? So that's 1 tick mark, so that's about right there. So this is where our x-intercept is going to be. Now the other x-intercept is at 3 pi over 4. We know that that is right here. So if I shift that over once, that's where my other x-intercept is. Now why would that be valuable to us? Check it out. If we have our x-intercepts right here, what's in the middle of them? The maximum. So I just go to the middle of those two and I put the maximum right there. See, I went in the middle of those two and I put the max right there. You guys see that?
It's gonna work every single time.
Yeah. And then the minimum is going to be right here. I know that, but let's just keep doing the minimum, like the in-between part. Where's my next x-intercept going to be? What's the distance between these? It looks like there's 1, 2, 3 tick marks. So we'll go 1, 2, 3, and we'll put right there. Then 1, 2, 3, and then we'll put one right there. And then, yeah, that'll be, we run out. 1, 2, 3. I guess we can put one right there too. Okay, so between these two x-intercepts, is it going to be max or min? Min. So we go down to 1.5. Between these two x-intercepts, max or min? See, I like this idea, Omar. Good job. So now I can easily just go, yeah. You like that? That's cool. I like that. Good idea. Okay. Sorry, this is a long video, but now we can put on our x-intercept.
Oh, it's a video?
Yeah, it's like 13. Guys, don't call out in the video. All right. Whenever you guys have a horizontal shift, whenever there's a phase shift, it's okay with me if you guys ignore the x-intercepts because x-intercepts start getting a little dirty. Now, can you figure it out? Yes, but it's not that important to me right now. Okay? Now, max and mins, we know. What are our max and mins?
1.5 and negative 1.5.
1.5 and negative 1.5.